Hello everyone, in this course we will learn about ultrasonic testing, including 1. The concept of ultrasonic testing, 2. The principle of ultrasonic testing, 3. Ultrasonic testing system, 4. Weld quality assessment, Part 1. Concept of ultrasonic testing. Ultrasonic testing is a non-destructive testing method that uses the propagation, reflection and refraction of ultrasonic waves in objects to find defects. It is mainly used to detect the internal defects of metal materials and some non-metal materials. Ultrasonic inspection has outstanding advantages such as low cost, convenient operation, large inspection thickness, and harmless to people and the environment, and experience effects. Part 2. Principles of ultrasonic testing. We mainly learn the principle of ultrasonic testing of a type display. First, the probe emits ultrasonic waves to propagate in the workpiece, and the acoustic waves are reflected when they encounter a heterogeneous interface and are received by the probe. Finally, the ultrasonic detector displays the relationship between the amplitude of the ultrasonic signal and the propagation time in the form of rectangular coordinates. The abscissa represents the propagation time of the sound wave, and the ordinate represents the signal amplitude. Part 3. Ultrasonic inspection system. Ultrasonic testing system includes ultrasonic testing instrument, probe and test block. We first understand the ultrasonic detector. Ultrasonic detector is the main equipment for detection. Its main function is to generate high-frequency electrical oscillations, and to stimulate the probe to emit ultrasonic waves. At the same time, it amplifies and processes the electrical signal sent back by the probe, and displays it in a certain way. At present, ultrasonic detectors widely used in weld inspection, such as CTS-22, HS-610E, etc., are type A display pulse reflection single-channel ultrasonic detectors. The picture shows a digital ultrasonic detector. 1. The instrument can input control data to the microprocessor by means of buttons or menus through man-machine dialogue, and then the microprocessor sends signals to control the work of each circuit. The microprocessor can also automatically adjust the instrument according to the preset program. 2. The digital ultrasonic flaw detector can automatically readjust the instrument according to the stored parameters. 3. The digitization of the detection waveform enables the instrument to further provide additional functions such as waveform recording and storage, automatic calculation and display of waveform parameters, automatic generation of distance wave amplitude curves, automatic adjustment of time baseline ratio, and spectrum analysis. Next, we will explain the probe. The single crystal oblique probe in the picture is composed of piezoelectric wafer, damping block, protective film, wedge, cable and shell. 1. Piezoelectric wafer. The function of piezoelectric wafer is to transmit and receive ultrasonic waves to realize electroacoustic energy conversion. Commonly used wafers are in the shape of a circle, a square or a rectangle. Both sides of the wafer need to be coated with silver layers as electrodes, so that the voltage on the wafer can be evenly distributed. 2. Damping block. The damping block can increase the vibration damping of the wafer, shorten the continuous vibration time of the wafer, and make the vibrating wafer return to a static state as soon as possible, which is conducive to the reception of the reflected wave signal by the wafer. 3. Protective film. The function of the protective film is to protect the piezoelectric chip from being worn or damaged. The protective film is divided into hard and soft protective film. Hard protective film is suitable for workpiece inspection with smooth surface. Soft protective film is used for workpiece inspection with rough surface. 4. Wedge. The wedge is a wedge installed in front of the wafer in the oblique probe in order to make the ultrasonic wave incident on the detection surface obliquely at a certain angle. 5. Cable. The connection between the cable probe and the detector needs to use a high-frequency coaxial cable. This cable can eliminate the influence of external electric waves on the excitation pulse and echo pulse of the probe, and prevent such high-frequency pulses from being transmitted the external radiation in the form of radio waves. 6. Shell. The function of the shell is to combine the parts together and protect them. Let's learn the test block. The test block is a test piece with a simple shape artificial reflector specially designed and manufactured according to a certain purpose. It is an integral part of the flaw detection equipment system, as well as an integral part of the flaw detection standard, and an important criterion for judging the quality of flaw detection. According to different purposes and requirements, test blocks are usually divided into the following two categories: standard test blocks and comparative test blocks. The picture shows the CSKEA standard test block and the CSKEA comparison test block. CSKEA test block. The standard test block specified in my country's non-destructive testing standard for pressure equipment NB T47013.3-2015 is obtained after improvement on the basis of the W test block. The CSKEA test block is a long horizontal hole comparison test block specified in the non-destructive testing standard NB T47013.3-2015 for pressure equipment. The main uses of the test block are as follows: testing the incident point and K value, setting the scanning speed, making a distance amplitude curve, adjusting the detection sensitivity, and comparing the defects. Part 4. Part 4. Weld quality assessment. Defect evaluation. The signal exceeding the evaluation line should be noted whether it has the characteristics of harmful defects such as cracks. If in doubt, change the probe angle, increase the flaw detection surface. Observe the dynamic waveform and make a judgment based on the structural process characteristics. 1. When the defect indication length is less than 10 mm, it shall be counted as 5 mm. 2. When two adjacent defects are in a straight line, and the distance between them is less than the length of the smaller defect, they should be treated as one defect, and the sum of the lengths of the two defects is used as the indicated length. Note: spacing does not count towards defect length. Classification of inspection results. 1. Defects whose maximum reflected wave amplitude does not exceed the evaluation line are rated as Class 1. 2. The non-cracked defects whose reflection amplitude is located in Zone I are rated as Grade 1-3. 3. When the inspector judges that it is a dangerous defect such as crack, regardless of its amplitude and size, it will be rated as Grade 3. 4. Defects whose maximum reflected wave amplitude is located in Zone 2 shall be rated according to the indicated length of the defect as specified in the table. 5. Defects whose reflected wave amplitude is located in Zone 3, regardless of their indicated length, are rated as Grade 3. That's all for this class. Thanks for watching.